Hello, good people. I have a question here under electronics BJT amplifiers. So in this video, I won't be solving this question. I'll be just explaining on how you do the calculations without having to cram the formulas. So here we are given a fixed bias. So how do I know that it is a fixed bias? So I know here they specified. So if they didn't specify, you would notice by this, because there's no emitter resistor there. So if there was emitter resistor, like if it was the same circuit but it has emitter resistor, it was gonna be emitter stabilized bias. So here, since there's no emitter resistor, then we know it is a fixed bias. But in this case, they have specified the kind of circuit that they give you. So if they didn't specify, you just have to know what kind of circuit you are dealing with. So after identifying that, you have to redraw the circuit. But to make things easier for you, you're going to have to draw two loops. You're going to have to draw base emitter loop and then collector emitter loop, so that you can be able to do the calculations. So after drawing two loops, then you're going to apply a KVL. And then after applying KVL, you solve what you need to solve. If they want a base current, you know you're going to use a base emitter loop. If they want a VCE, you know you're going to use collector emitter loop. So by not wasting any time, let me just get straight to the point. So you redraw the same circuit, but you include the loops. So as you can see, I have here there is still the same RP, VPE is here, and then what I did was to share the VCC because they were sharing the same VCC. So I decided to cut it off and then bring it this side, and then again for collector emitter loop, I brought it this side so that you can have two loops. It's gonna be, let me call it one, and then this one, let me call it two, loop two. So after redrawing your thing, you have to assign the polarities in your resistors. So as you know, the current flows in this direction. So it means it's gonna flow, but then you know that a resistor resists the flow of current. So since the current flows in this direction, we're gonna have positive here and then negative here. Same applies. The current flows, when it gets here, it flows this way. So we have positive here, negative here. Now we go on the collector emitter loop. So we know current flows from positive to negative. It flows like this. So you know the function of resistor, it resists the flow of current. So it's going to be positive and negative, and even here positive and negative. All right. So after assigning your polarities across the resistors, you have to apply KVL. So when you are applying KVL, you check what you see first. So you see the sign that you see first when you go in clockwise. So it's up to you whether you go clockwise or counterclockwise. So I chose to go clockwise in both loops. So since I'm going clockwise, the same side, the first sign that I see here, it is negative VCC, and then I go with it like this. What do I see? I see positive IB RB, and then as I'm going, I see positive VBE, and this equals 0. Now let's say maybe you want to solve for IB. You know what to do. You take a VCC and VBE to the other side, and then you're going to be left with IB RB equals to, when you take VCC, the other side is going to be positive. It's going to be VCC, and then VBE is going to be negative. It's going to be minus VBE. And then to solve for IB, we divide by RB. Even to solve for RB, we divide by IB. So once you have this equation, then you're okay. You can solve for whatever that you want to solve. So let me just solve for IB. So you see IB equals to VCC minus VBE over RB. So now you know the formula without having to cram the formula. You see? So yeah, so that's for base emitter loop. So now let's go to collector emitter loop. This one. We're still gonna do the same thing. We're going clockwise. So what do we see first? We see negative VCE. You write negative VCE, and then as you go, what do you see? See negative ICRC, negative ICRC, and then as you go and go, what do you see? You see positive VCC. So it's gonna be plus VCC equals to 0. Since we have this formula, you can solve for anything. You can solve for VCE, you can solve for IC if you are not given you're not given the gain, or you can also solve for RC. So let me just solve for VCE. So you're gonna say VCE. Well, you're gonna take VCE to the other side. So when you take VCE to the other side, it's gonna be positive, and then you're gonna be left with a positive VCC minus ICRC. So this is how you get the formulas without having to cram them. For this kind of a question. So another thing, this one you have to cram it, or you have to know it. It is very, very important. Gain equals to collector current over base current. You have to know it, and it is very, very important. And then you should also know that if they didn't give you the value of VBE, you should know that VBE equals to 0.7 volts. So these two you can cram them, but these ones you don't have to. You just have to do all those steps that I gave you. So first step, you have to identify the type of the circuit that they gave you, and then you draw two loops, a base emitter loop and collector emitter loop. After drawing those loops, you assign the polarities, and then after assigning polarities, you apply KVL, and then after applying KVL, you can have your formula, your equation, and then from equation you just plug in the values, and then you solve for the unknown. So that's all for this video.